Hi, welcome back to a new lesson. This is Lakshmikant Tiwari. In this lesson, I am going to teach about decision tree in machine learning using a Python. Okay, in previously I have also taught few other lessons. If you see here, I have taught about the SVM, logistic regression, KNN algorithms, and the linear regressions and other Python getting started tutorials. But in this lesson, I'll be talking about the first theory of the decision tree, which will be around the 10 minutes of the lecture, and then I'll explain example decision tree with an example. Then we will understand why we need a decision tree and how decision tree works, and then finally we will see that what are the important the attribute selection measurements while working with the decision tree, like information gain, gain ratio, and the Gini index. And after that, I'll tell you how you can pass a parameter to optimize your decision tree. And then I'll tell you when to stop splitting and what is the pruning in the decision tree. And then finally, I'll show you the two examples, one with the decision tree regression. And in that, I'll take about very famous data set, diabetes data set. And the another examples, I'll talk about the decision tree regressor. A decision tree regressor, of course, and another example is a decision tree classifier. And while working with the decision tree classifier, I'll be working with the iris dataset, in which we need to predict three classes of flower: setosa, versicolor, and virginica. And then we will see it, visualize it with the pair plot, and then finally we will plot a confusion matrix here. And after that, finally we will plot a classification report, and after that we will understand what is the advantage and the disadvantage of a decision tree. So let's do not waste the time. Let's get started with the decision tree in machine learning using a Python. Decision tree is a general predictive modeling tool that has application spanning a number of different areas. In general, decision trees are constructed via an algorithmic approach that identifies ways to split a data set based on a different condition. It is one of the most widely used and practical methods for supervised learning. Decision trees are a non-parametric supervised learning method used for both classification and the regression task. In this lectures, I'll be taking an example of a classification as well as for a regression. The goal is to create a model that predicts the value of a target variable by using a regression as well as a classification algorithm. Although if you want to learn more about the about the decision tree, the mathematics, then you can go ahead and download this book, An Introduction to Statistical Learning, and this is available in a free. Although this is application in R, but you can download this and you can understand its mathematics. Okay, perfect. So the moreover, the decision tree is a flowchart-like tree structure where an internal node that represents the feature and the branch represents a decision rule. Okay, and these are the decision rule, and this node is root node, and these nodes are a leaf node. And it learns the partition on the basis of these features value, which is widely known as attribute value. It partitions the tree in a recursive manner which is known as a recursive partitioning. This flowchart-like structure helps you in decision makings. It's a kind of human decision makings. So it's a visualization like a flowchart diagram, which easily mimics the human level thinking. That is why a decision tree are easy to understand and interpret. So the moreover, we can say that the decision tree classify the example by sorting them down the tree from the root to the leaf nodes, and with leaf nodes providing the classification to the examples, that is a final label to the any rows of the data. So each node in the tree act as a test cases for some features or some attributes, and each edge, okay, so each edge descending from the node to the one of the possible answer to the test cases. So these you can say the edge. Okay, this process is recursive in nature and is repeated for every subtree root at the new nodes. So let's, for example, this is your root node and it has many other nodes. So the first node is known as a root node, but if we take this tree as, okay, then this will be a subtree, okay. Otherwise you can say this is a subtree, and for this subtree this decision node is a root node. Okay, so let's understand this with an example there, and this is a very famous example. Here you see in any machine learning the example, generally lecturers start with this example, where let's suppose that where one of my friend, I need to predict the probability of one of my friend whether gonna come to play with me or not, and there the weather conditions are given there, and based on this we need to predict whether the person is coming to play or not. And the feature, there are 4 features are given there: weather, temperature, humidity and the wind. Based on these 4 features I need to decide whether my friend will come to play or not. Okay, perfect. So let's say for the Saturday, how will you decide whether to play or not? Okay, so let's say you go out and check if it is hot and the cold, and you check the humidity, you check the wind speed, etc, etc. Based on that you need to make a decision whether your friend will come to play or not. This is really very simple, but if data size and the number of feature increases, then it becomes very difficult by doing a manual. Okay, perfect. Now let's go ahead and understand why the decision tree. Decision tree often mimics the human level thinking, so it's so simple to understand the data and make some good interpretations. And decision trees actually make you see the logic for the data to interpret, not like black box algorithms like SVM, KNN, neural networks, etc. So this is really very simple. So these are the basic two the main reasons why we go with the decision tree, and this is really the very fast as comparison to other algorithms. Now the question is how this decision tree works. Okay, so as I told you earlier that we start from the top, which is known as root, and then based on these attributes we make some decisions, and those decisions are being made on these edges. Let's say if we take for this example, we need to first understand for a weather. Okay, so if weather is sunny or rainy or cloudy. Okay, if you see here, if weather is cloudy, then the play is S. If weather is cloudy, play is S. If weather is cloudy, and S. Okay, so whenever the weather is cloudy, no matter what is the temperature, humidity or wind, play is always yes. That's mean if weather is cloudy, my friend is coming to play. So in that case we don't need to check the humidity, wind and the temperature. So it directly classify, it only checks the weather cloudy, then it says that yes. But if weather is not cloudy, let's say if it is sunny and the rainy, then it need to check with the humidity, wind and the temperature as well. But for this example we have just the humidity and the wind. So let's go ahead and see if weather is sunny and then what is the humidity, and based on this humidity we need to make a decision. Let's say weather is sunny and the humidity is high, then person will come to play. So here you see here a person will not come to play, and similarly if weather is sunny, humidity is high, person will not come to play, and if humidity is normal, then the person will come to the play. So this is kind of the recursive nature, the recursive splitting, and for each attributes we keep checking whether until we reaches to the leaf node. So here is a very simple algorithm. Select the best attribute using attribute selection measure to split the records. Okay, I'll tell you later what is the attribute selection measures, and this is actually the attribute selection measures. Attribute selection measure is based on the information gain ratio and the Gini index. I'll tell you it in detail. Then make that attribute a decision node and breaks the dataset into a smaller subsets. And after that starts tree building by repeating this process recursively for each child until one of the condition will match, and those conditions are if all the tuple belongs to the same attribute values, Okay, and there are no more remaining attributes, that's mean the feature you can say, and there are no more instances. Okay, that's mean there is no more data, etc. and etc. So based on that you can stop. Okay, so the good news is that the scikit-learn library in a Python has made all these things very easy, so you don't need to go with these rules, although this is always good to know these rules. So scikit-learn automatically implement these rules. You just need to select the decision tree classifier and decision tree regressor, and then it automatically do the rest of the things for you. Now let's go ahead and see how these decision tree algorithms are built. Basically there are two types. From where these decision tree algorithms are made. The first one is the cart and another one is the ID3. The cart is the classification and the regression tree. It uses a Gini index as attribute selection measures, and ID3 uses entropy function and information gain as a attribute selection measure. Now let's go ahead and understand what is the attribute selection measures in a decision tree. So these attribute selection measures are information gain ratio and a Gini index. If you want to learn more about these mathematics behind these three attribute selection measures, then go ahead and read chapter 8 of statistical learning. Okay, now what is the information gain? Information gain is based on the entropy and the entropy. So you first need to understand what is the entropy. Entropy is a measure of the amount of uncertainty in a data set. Okay, so the more uncertainty into the data set, the more entropy, and based on that one, and then based on that one we compute the information gain. Okay, so the information gain is a measure of a difference in entropy from before to after the set S is split on an attribute. So let's see here, this is the first attribute and here is the second attribute. So we see that what is the information gain after splitting based on this attribute Sunny, and it comes to this node. We see what is the information gain if we split on from this node to this node. So based on this one, and this basically we measure from the entropy difference, and then we decide whether we need to go this way or this way. Okay, or this way or this way. So based on this we decide how to descend in a decision tree. And the another attribute, another decision making the selection measure is the gain ratio. So the gain ratio, the information gain formula used by ID3, right? So here ID3 information gain formula used by ID3 treats all the variables the same regardless of their distribution and their importance. So this is a problem when it comes to continuous variable or discrete variable with many possible values, because the training examples may be few and far between for each possible values. Okay, so the one way to avoid this is to use some other measures to find the best attribute instead of just the information gain. So the alternative measure to information gain is a gain ratio. So the gain ratio tries to correct the information gains bias toward the attributes with many possible values by adding a denominator to information gain called split information, and this split information tries to measure how broadly and uniformly the attribute splits the data. Although I am leaving this mathematics, you can go ahead and read the chapter 8 to understand this mathematics a little bit more deep. Okay, now let's go ahead and see what is the Gini index. Gini index is a measure for a likelihood of an incorrect classification of a new instance of a random variable. So if that new instance were randomly classified according to distribution of class labels from the dataset. If our dataset, let's say, is pure, then likelihood of incorrect classification is 0. If our sample is mixture of different classes, then likelihood is incorrect classification will be high. So this is how the Gini index works. So basically it works on a measurement of the likelihood of an incorrect classification. Okay, so these are the three attribute selection measurements, and finally we understand how we can optimize the decision tree. So there are basically three criteria to optimize the decision tree. First, to choose the criteria, and in the criteria we see whether we want to go with the Gini index or entropy based, and then with the splitter. These parameters we need to pass into sklearn library, and in the splitter what we want, whether we want to use a random split or a best split, and then the max depth. I mean, what would be the depth or maximum depth for a decision tree to check whether this is a perfect or whether it is a perfect or a best classification or not. So these are the three basic the parameter which we will be passing into the decision tree classifier. Okay, so now let's go ahead and see how when we need to learn when it is going to stop. Okay, so you might ask when to stop growing a tree. As a problem usually has a large set of the features, it results in a large number of split, which in turn give a huge tree, and such trees are complex, and it can lead to the overfitting. That is where we need to pass a max depth. We can somehow sometimes we can set the max depth some particular number, let's say 10, 50 or 100. Then the decision tree will not go beyond the 10, 50 or 100. Okay, and then it will stop. And the another way to work with this is known as a pruning. Okay, in general, you know here how it prunes. The performance of a tree can be further increased by pruning. It involves removing the branches that make use of features having low importance. So this way we reduce the complexity of the tree and thus increase its predictive power by reducing the overfitting. Pruning can start either from root or a leaf. The simplest methods of pruning starts at the leaves and removes each node with the most popular class in that leaf, and this change is kept if it doesn't deteriorate the performance. So let's go ahead and see here. The most famous in this one, the most occur leaf is no loan. That's why it removes this particular the subtree and it places this to the no loan. And it says that it sees if the performance doesn't deteriorate, then it keeps no loan, otherwise it doesn't prune this. It doesn't prune this subtree. So this is the basic idea behind the pruning and how it increase the accuracy or speed of your decision tree. So this is all about in the theory. Now let's go ahead and learn the decision tree regressor and decision tree classifier with the sklearn in a Python. So okay, we will start first by importing the necessary packages into a Python. So let's go ahead and first import a necessary package which we need here, and those are the pandas, seaborn, matplotlib, numpy, and other libraries like sklearn. Okay, so here we import pandas as pd, and then here we import seaborn as sns, and then we import numpy as np, and then finally we import matplotlib.plyplot as plt. Okay, and then finally we say here matplotlib inline. Okay, now we have imported necessary libraries. Now let's go ahead and import sklearn from here. So the from sklearn import data sets, and then we also need to import metrics, and from sklearn dot model selection we need to import train test split. Okay, perfect. Then from scalar dot pre-processing, although we don't need standard scalar here. Now let's go ahead and import here the sklearn.tree. Okay, and import here the decision tree classifier. Sorry. So here we have two decision tree classifier and the regressor, but here we are going to first get the decision tree regressor, and after that we will go ahead with the decision tree classifier. Okay, perfect. So here we have our necessary libraries imported. Now let's go ahead and get the data, and here I am going to get the data, diabetes data. So let's go ahead and load this diabetes data from the Seaborn. Okay, diabetes is equal to the diabetes is equal to datasets dot load datasets diabetes. Okay, now we have got the diabetes datasets. Now let's go ahead and see the keys of this diabetes dataset. Sorry, it says that we have a data, target, description, feature names, and the data file and the target file name, etc. So now let's go ahead and see here the description of this diabetes. In the description, you see here it says that there are 10 columns, and that is the feature actually, and it has many other the columns are age, sex, body mass, average blood pressures, and here the blood serums. Okay, S1, S2, S5, S3, S4, S5, and the S6, and these 10 features variables have been mean centered and scaled by standard deviation times. That's mean we don't need to do standardization or a normalization. Okay, and the target here, if you see here, the target is a measure of disease progression 1 year after the baseline, and the baseline is given into this data. Now let's go ahead and see the feature names, and in feature names we have here feature names. These are the feature names, the 10 feature names, and the diabetes, the target. Here we have, this is the target, and this is the progression of diabetes after 1 year of the baseline. Okay, now let's go ahead and get the data into x and the y vector. So here we have x is equal to the diabetes dot data, and here we have y is equal to diabetes dot target. Perfect. Now let's go ahead and see the shape of x and y. It says that 442 rows are there. If you verify with this description, it also says that there are total 442 instances of your data. Now let's go ahead and do a pair plot using Seaborn library there. But before doing a pair plot, I need to create a data frame, pandas data frame, otherwise pair plot would not work. So I can do with the df, that's the data frame, is equal to pd dot data frame x, that's the feature vector, and then I'm gonna give here the column name. The column name is the diabetes dot feature names, and then I'm gonna also put here the y target there. Now let's go ahead and see this df data frame. So here we have now 11 rows, 11 columns there. The first 10 columns are features, and then we have a target. Now let's go ahead and see it with the pair plot, SNS pair plot, and there we have df. Okay, so it might take a little time since there are so many columns here. It will make 11 cross 11 matrix pair plot there. Just wait for a few seconds, it will return final the pair plot. Okay, perfect. Although this is a quite big pair plot, you might not get a lot of the information from here. And if you see here, this is the target, the last one is the target, and you see here there is a kind of linear relation in between the target and other variable like S6 and S5 there, although you would not get much information from S4, but you can also get some information from S3 in the target there. So from here you can get that the necessary information. So the moreover with this one, I can see here there is some kind of the linear relation from S6 and the S5 with the target. Okay, so these are the blood serum, blood serum, the features from blood serum S6 and S5. Now let's go ahead and build a decision tree, the regression. Okay. Now let's go ahead and build a decision tree regressor. So we need to first divide our data set into train and test split. There I can do x underscore train and then underscore test. Sorry, this should be the x underscore test, and then I have y underscore train and then y underscore test is equal to the train test split, and then finally I need to pass x and the y, and then I need to also pass here the test size. The test size I am going to put here the 20% for testing and 80% for the training. And let's go ahead and put here the random state so that we can get a same result as I am going with this one. Okay, so here I have x train and the x test. Now let's go ahead and build a regressor is equal to decision tree regressor, and in this I am going to pass here random state is equal to 42. Now if you press here shift and the double tab, you will get other the information which we can pass here. Okay, like max depth, splitter, etc, etc. So we are not going to pass other information, and we are just keeping max depth is equal to the none. In that case, the decision tree regressor will iterate until it reaches a maximum depth. Okay, now let's go ahead and fit this regressor with regressor.fit, and then we need to pass here x train and then y train. And once we have fitted this, let's go ahead and predict there. Y pred is equal to regressor dot predict. Okay, and there I need to pass underscore x underscore test. So if you see here, we have y predictions. Now let's go ahead and see how this y predicted and the actual y is matching together. Okay, and for that we need to do the plot. So let's go ahead and do a plt plot dot figure. There I am going to first set a fixed size. Okay, and the fixed size I'm going to set here 16 by 4, and then I'm gonna do here the plt dot plot, and in that I'm gonna pass here y pred and then plt dot plot, sorry, and then I'm gonna pass here y test. So now you see here you have y prediction and y test, right? So you can see here it's a kind of the quite matching with the true value of y and the predicted value of y. Now let's go ahead and find out what is the mean square error, or the root mean square, RMSE root mean square error in this prediction. So we can get that by calling metrics and mean square error from scikit-learn. So let's go ahead and do sqrt np.sqrt there, then metrics we have, and then we have a metrics dot mean squared error, and in that we need to pass here the true value, that is the y test, and then y predicted. Okay, so in this way we will get here the mean square error, root mean square error is 70.61. Now let's go ahead and see what is the standard deviation of the true data. Okay, to get the standard deviation of the true data is y test dot std, and in this you will get here the 72.78. So with this you can see here the true data standard deviation is the 72, and the root mean square error of our predicted data is 70. So the moreover I can say that the predicted data the error in predicted data is less than the standard deviation, which I can say that it's pretty good, the good model. Okay, although I cannot say it is the very best model, but this is a kind of the good model where the root mean square error value is less than the standard deviation of the data, of the true data. Okay, so this is how we can work, how we can use a decision tree as a regressor. Now I am going to show you how you can use a decision tree as a classifier. Okay. Now to use a decision tree as a classifier, I need to first import a decision tree classifier from sklearn. So let's go ahead, import that from sklearn.tree, and then import decision tree classifier. Okay, now I am going to load here the iris dataset, very famous dataset, iris dataset. Every the data scientist enthusiasts are beginners start working with iris dataset in general, or a Boston dataset. So here we have an iris dataset. Let's go ahead and load this iris dataset. Okay, now let's see how many classes and how many classes to predict and how many features are present into the iris dataset. So here I'm gonna first the print iris classes which we need to predict there. So it has iris, then the target names. So here we have three type of the flower name, that is the Setosa, versicolor, and Virginica. So these are the three target names which we will be predicting in our classifier. And then let's go ahead and see how many features are there. And there are 4 features: sepal length and sepal width, as well as a petal length and petal width. Now let's go ahead and load this data into x and the y vectors. There I can get here x is equal to the iris dot data, and then y is equal to iris dot target. Okay, so there now I have got x and the y data. Now let's go ahead and visualize this x and the y. Let's go ahead and visualize into the seaborn pair plot. And to visualize into the seaborn pair plot, we need to first create a pandas data frame. So the pd dot data frame, here I have x and the column names there, sorry, the x and columns names I'm gonna put here iris dot feature name, and then a new target variable I'm gonna add here the target is equal to the y. And let's go ahead and visualize first few lines of data frame. So here we have a target. The 0 is Setosa, 1 is versicolor, and 2 is Virginica. Now let's go ahead and do a seaborn pair plot, sns dot pair plot, and then the df. So in this you will get a pair plot, 5x5 pair plot. Now you see here, this is the target. So if you see here, there is kind of the relationship between the petal length, width, and sepal length and the width. If petal width is high and the petal length is high, then you see here there is very high probability that target is the 2, that is the Virginica. Okay, that's the Virginica. So this is the flower type, and in this way we can train our algorithms. We can train our algorithm to classify it with the machine learning algorithm. Okay, now let's go ahead and get our data by using train and the test split. I'll be using 80% data for the training and the 20% data for the testing. Okay, so it's as usual x train, and here we have x test, and then y train, and then y test is equal to the train test split, and in that I need to pass xy and then here a random state. Okay, so the random state here I'm gonna pass here let's say the 1, and of course I need to pass here the test size as well. The test size I'm gonna use 0.2, and stratify, very useful. Stratify is equal to the y. Okay, if you don't know what is the stratify, go ahead and watch my previous videos. There I have explained what is the stratify. Actually, the stratify will make sure that the data should split accordingly. There should be the 20% of each classes into the target variable, that is the y, and we decide that stratify y from here. Otherwise you can go ahead and Google it, what is the stratify in machine learning. Okay, now let's go ahead and build a classifier. CLF is equal to decision tree classifier, and in this I am going to pass here a criterion. The criteria is Guinea. If you remember my theory part there, I have explained what are the other criteria which you can use. Now let's go ahead and select random state is equal to the 1, and now I am going to fit our the model CLF.fit x train and then y train. There, now I have got now this will fit the model. Now let's go ahead and predict the y. Pred is equal to the CLF dot predict. Okay, and now let's pass here x test. So here we have got y pred. Now let's go ahead and get the accuracy, and for the accuracy what I need to do here, accuracy is equal to matrix dot accuracy score, and in that I need to pass here the true value of y, that is the y test, and the predicted value of the y. It will say that here we have got 96.67% of the accuracy, okay, with the decision tree. Now let's go ahead and draw a confusion matrix. Okay, to draw a confusion matrix, what we can do here, for a confusion matrix we can first get a confusion matrix there, that we get from matrix dot confusion matrix. In that we pass a true value of y and predicted value of y. So if you see here, we have got a confusion matrix. You see here, this is a confusion matrix. Now we need to visualize this using a Seaborn library. So you can do with seaborn.heatmap, and in that I can pass here a mat, and then a square will make sure that the plotted graph should be a square graph, and then a note is equal to the true, and then here the format is decimal, and the color bar here I'm gonna make here a false. Okay, and then here I'm gonna put x tick labels. The x tick labels is iris dot the target names, and similarly y tick labels is equal to iris dot target names. Okay, so in this way we will get here our the confusion matrix. Now let's go ahead and keep x and the y label there, so we can give here plt dot x label, and the x label is the predicted value, and the plt dot y label is the true value. Okay, perfect. Now you see here, so this is the predicted value and this is the true value. Okay, perfect. So here we have got for the Setosa, versicolor and the Virginica. Right, now let's go ahead and finally see a classification report, and after that I'll stop this tutorial. Let's go ahead and get that with the print the matrix dot classification report. With the classification report I can get y test, sorry, if I pass y test and y pred, I can get here precision recall F1 score. So this says that around 97% of the accuracy has been achieved. To be precise, it is a 96.67% of the accuracy. So precision recall and the F1 score is around 97% with this decision tree algorithm. Perfect. Now let's go ahead and see what is the pros and the cons for a decision tree algorithm. The advantage of a decision tree algorithms are it is very easy to interpret and visualize, and it can easily capture nonlinear patterns as well. Decision tree requires fewer data processing from the user, and there is no need to normalize the columns. That means there is no need to do the standardizations and the normalization. It can be used for feature engineering such as predicting missing values, suitable for variable selections, etc. etc. And the decision tree has no assumptions about distributions because of non-parametric nature of this algorithm. But there are some disadvantages for a decision tree, like it is very sensitive to the noise and it can overfit noisy data. In the next lesson, I'll tell you about the random forest which can never overfit. The small variation in the data can result in a different decision tree, and this can be reduced by Bayesian the boosting algorithm, which will result as a random forest algorithm. And the decision trees are biased with the imbalanced data set. So it is always recommended that you should always use a balanced data set. Otherwise, you might not get a good result. Okay, so this is all about in this lesson. In the next lesson, I'll be talking about the random forest. Thank you so much for watching this video. Please do not forget to subscribe this channel. Bye bye. Have a nice day.